The last normal thing Alex did was check the outside temperature. -31. Wind from the northeast, 7 meters per second. Standard. He wrote it in the log, capped the pen and set it on the desk next to a half-eaten cracker and a mug of tea that had gone cold 2 hours ago. That was 6:47 in the morning, station time. At 6:48, the world stopped. Not metaphorically, not gradually. The planet that had been spinning without pause for 4.5 billion years, longer than the sun has had its current colour, longer than the moon has existed, longer than any rock on the surface of this earth, simply stopped. 1 second it was moving, the next it wasn't. Alex didn't understand what happened for about 4 seconds. He felt it as a jolt, not violent, more like the sensation when an elevator stops and your body doesn't quite agree with the decision. The mug slid 3 centimeters toward the window. The pen rolled off the desk. Somewhere in the back of the station, something metal fell. Then came the sound. Low, continuous, from the south. Not an explosion, not a crash. Something older than either of those things. A frequency you feel in your back teeth before your ears process it as sound. The kind of sound that something makes when it's very large and very far away and completely, catastrophically wrong. Alex went to the window. The sky to the south was the colour of old paper. Then, while he watched, it shifted toward orange, toward something that had no good name in any meteorological vocabulary he knew. On the horizon, maybe 800 kilometers away, maybe more, a line appeared, brown, moving. He didn't know it yet, but what he was watching was the atmosphere of an entire planet, still moving east at 1,600 kilometers per hour, while the ground beneath it had just stopped. He stood at that window for 11 minutes before he understood that he was alive, and that almost everyone else wasn't. Here is what you need to know before anything else. Right now, as you listen to this, your body is moving east. Not slowly, not gently. At the equator, Ecuador, Kenya, Indonesia, the surface of the Earth moves at roughly 1,670 kilometers per hour, twice the speed of sound. A fighter jet at full afterburner barely keeps pace with a point on the ground at the equator. You don't feel it because you're moving with it. The air, the water, the ground, you, all of it together, one system, one speed. But take away the ground. Stop only the ground. And everything else, the air, the ocean, you, keeps going. At 1,670 kilometers per hour, east. Alex was at the North Pole, or near enough. At that latitude, the rotational speed drops to almost nothing. The axis of the planet passes almost directly through where he was standing. He wasn't moving at 1,600, he was moving at something close to zero. That is the only reason this story exists. Every other person below 60 degrees latitude, every city, every coast, every building not bolted directly into bedrock, was hit by an inertial force that physics doesn't have a polite way to describe. Imagine a car braking from 60 kilometers per hour, hard enough to break bones. That's the analogy people use. Except the speed here wasn't 60, it was 1,600. Alex stood at the window. The brown line on the horizon was getting taller. He could hear the station creaking, not the familiar thermal contraction creak of Arctic nights, but something slower, deeper, like a ship in heavy water. He picked up the pen from the floor, put it back on the desk, watched it stay there, and thought, with complete and almost embarrassing clarity, I need to find out if the radio still works. The radio worked. Partially. 2 frequencies out of 11. One was static with something underneath it that might have been a voice and might have been interference. The other was a Norwegian weather station, automated, reading out wind data for a location that no longer had wind in any direction that matched the instruments. Alex listened to it for a while anyway. The numbers were wrong. The compass was wrong. Outside, the brown line on the southern horizon had stopped growing and was just sitting there now, a permanent smear across the sky like something spilled on glass that nobody had wiped. He made tea, the second mug. This one he drank. And while he drank it, he tried to think about what had actually happened. Here's the problem with that exercise. The human brain is not built for this scale. It handles car accidents reasonably well. It handles fires, floods, the death of people it knows. Evolution spent a long time tuning it for dangers that fit inside a single field of vision. A predator, a storm, a rival, not a planet. When something happens at planetary scale, the brain does something specific. It finds the smallest possible task and executes it with total concentration. Alex checked the temperature log. He fixed the radio antenna connection that had been loose for 3 weeks. He ate the other half of the cracker. His hands were steady. That was the part that bothered him most, later. So, what actually happened? The Earth rotates. This is not a background fact, not scenery. It is the central mechanical fact of this planet, the thing from which almost everything else follows. The length of a day, the direction of winds, the path of ocean currents, the existence of a magnetic field, the shape of the planet itself. All of it downstream from one thing, the ground moving east at speeds that make aircraft look slow. For 4.5 billion years it hasn't stopped, not once, not for a second. And the question, the one that scientists run as a thought experiment because no force in nature could actually cause it, because stopping a planet requires hitting it with another planet, and even then you mostly just change the angle. The question is, what happens when it does? The answer splits into layers. The first layer is the first second. That's inertia, the atmosphere, the oceans, the soil, the buildings, the people, everything that isn't fused directly to bedrock, all of it continuing east while the ground stops. That layer is immediate and it is total. No preparation, no warning, no gradual onset. The second layer is the first hours. That's heat, water, tectonic response. The third layer is the first years. That's climate, magnetic field, the redistribution of the oceans. The fourth layer is what's left after all of that. That fourth layer is the one worth thinking about longest. Alex drank his tea. Outside, the sky to the south was the colour of a bruise now, purple-brown, massive, lit from below by something he didn't want to identify. The temperature outside had dropped 4 degrees in 20 minutes, which made no immediate meteorological sense, and he wrote that in the log too. The pen didn't roll this time. Nothing was rolling anymore. 4.5 billion years ago, there was no Earth. There was a cloud. Gas and dust drifting in no particular direction. Part of a larger cloud, part of a larger structure still. An arm of a galaxy that hadn't yet developed the name we'd give it. Inside the cloud, particles moved. They collided, scattered, attracted each other, collided again. Random, chaotic, no pattern. Then something disturbed it. Maybe a shockwave from a nearby star that had just ended. A supernova, a pressure pulse moving outward through space at a fraction of the speed of light. Invisible, silent, arriving without announcement. Maybe just the accumulated gravity of the cloud itself finally reaching a tipping point. Either way, the cloud began to collapse inward. And here is where something non-obvious happens. Inside that cloud, all that random, chaotic movement of particles, all those collisions and scatterings, added up to a tiny net rotation. Not much, not organized. Just a slight statistical bias in one direction, the way a coin flipped 1,000 times might come up heads 530 times instead of exactly 500. When the cloud collapsed, that tiny bias mattered enormously. There's a law in physics called conservation of angular momentum. It has no exceptions. A figure skater pulling her arms inward spins faster, not because she's pushing harder, because the radius decreases and the math requires the speed to increase. The total momentum stays constant, it just concentrates. The collapsing cloud was the same thing at a scale that doesn't fit comfortably in the imagination. As the radius shrank from something measured in light years to something measured in kilometers, that tiny statistical rotation concentrated and concentrated and concentrated until the resulting disk was spinning fast enough to flatten itself, to sort itself, to begin forming planets from the debris. The Earth formed inside that spinning disk. Every rock that fell onto it, every chunk of ice, every collision during those first hundreds of millions of years added rotational momentum. The planet was spinning before it was finished forming. Then came the impact. Roughly 4.5 billion years ago, while the Earth was still young enough that its surface was largely molten, while the crust was thin and unstable and the interior was churning, something hit it. An object roughly the size of Mars. Not an asteroid, not a comet, a planet. A full planet, moving at a speed and angle that planetary scientists still argue about in the details but agree on in the broad strokes. The impact was not a collision in any sense that word usually implies. It was more like two liquids mixing at enormous velocity. The impactor, called Theia, named after a titan from Greek mythology, the mother of the moon, didn't bounce off. It didn't crater. It largely merged with the Earth, its iron core sinking toward ours, its mantle splashing outward into space in a ring of debris that would spend the next few thousand years accumulating into the moon. And that impact gave Earth an additional rotational kick. Right after the collision, according to the calculations, a day on Earth lasted approximately 5 hours. 5 hours. Sunrise, a few hours of light, sunset, night, all of it in the time it now takes to watch 2 films back to back. Since then, the Earth has been slowing down. The mechanism is the moon itself. The moon's gravity pulls on the oceans, creating tides, those bulges of water that follow the moon around as the planet rotates beneath them. Those bulges create friction, a tiny drag. Completely imperceptible on any human timescale, but cumulative over billions of years. Every 100 years, a day gets approximately 2 milliseconds longer. 2 milliseconds. It sounds like nothing. Over 4 billion years, it adds up to hours. And the angular momentum the Earth loses doesn't disappear. It transfers to the moon, which responds by slowly moving away from us, about 4 centimeters per year. The moon is drifting outward, slowly but measurably in a direction away from Earth, carrying with it the rotation it stole. This process will continue. In 200 million years, a day will be 25 hours. In several billion years, if the Earth and Moon survive long enough, they will reach a state called tidal locking, the same face of the Earth always pointing at the Moon, one eternal day on one side, one eternal night on the other. Alex knew some of this, not all of it, not the numbers, but the outline. He'd read something once, years ago, about the moon slowing the Earth's rotation. He remembered thinking it was interesting in an abstract way, the kind of fact you store and never use. He thought about it now, standing at the window with his second mug of tea, watching the brown sky to the south not move. The thing about tidal locking is that it isn't catastrophic. It's slow. Millions of years slow. Life has time to adjust, to adapt, to find new rhythms. The geological record shows that organisms have been recalibrating to the changing length of a day for as long as there has been life on this planet. Gradual is survivable. Gradual is what evolution is built for. What had just happened outside was not gradual. He checked the outside temperature again. -39. 8 degrees in 40 minutes. He wrote it down. Let's go back to that moment. 6:48 in the morning, station time. The pen rolls off the desk. Something metal falls in the back room. The mug moves 3 centimeters toward the window. That was Alex's experience of it. Here is what was happening everywhere else. At the equator, every person, every animal, every tree, every building, every cubic meter of soil that wasn't fused directly to the bedrock underneath it was moving east at 1,670 kilometers per hour. The ground stopped. They didn't. Newton's first law has no compassion built into it. A body in motion continues in motion until something stops it. The ground was no longer doing that job. Everything lifted, not slowly, not dramatically the way things lift in films, just gone. One frame present, next frame airborne, continuing east at the speed they'd always been moving, the speed they'd never felt because the world had always been moving with them. NASA physicist Stan Odenwald described it simply. Anything not anchored into solid rock would be swept away. People, animals, trees, cars, buildings, the topsoil itself, all of it continuing east while the rock beneath sat still. The atmosphere did the same thing. Air is not attached to the ground. It moves with the ground through friction and pressure, but that connection has limits. When the ground stopped, the lower atmosphere kept going, a planet-wide wind at equatorial latitudes of roughly 1,600 kilometers per hour, moving east, stripping everything in its path. For context, the strongest tornado wind ever recorded on Earth reached approximately 500 kilometers per hour. That was a local event. It lasted minutes. It destroyed everything it touched. This was the entire equatorial band of the planet, continuous, for hours. Geologist James Zimbelman put it this way. At those forces, the crust itself would likely fracture. The stresses involved exceed what holds rock together. The upper crust and mantle, in his assessment, would, in the most extreme scenario, become a cloud of debris and molten material. But we're running a thought experiment here, so assume the crust holds. What then? The kinetic energy of all that moving air has to go somewhere. Physics is strict about this. Energy doesn't disappear, it converts. The atmosphere moving against a stationary surface converts its momentum into heat through friction, the same way your hands warm when you rub them together, except the scale is continental and the temperatures involved are not the kind that warm hands. Along the equatorial belt, air temperatures in the hours after the stop would rise to levels that don't have good reference points in normal human experience. Metals with low melting points would become liquid. Organic material, wood, plastic, everything that grows or is made from things that grew, would combust without flame, simply from the temperature of the air around it. The forests of the equator would not burn, they would cook. Then the oceans. Water has more inertia than air, a lot more. The world's oceans, covering more than 70% of the planet's surface, would continue moving east long after the atmosphere had begun to slow. The result? Waves. Not waves in any normal sense of that word. Walls of water kilometers high, driven by the momentum of entire ocean basins. Think of it this way. Imagine a bathtub full of water. You slide the bathtub forward across the floor and then stop it suddenly. The water doesn't stop. It keeps moving, sloshes forward, climbs the front wall of the tub, slops over the edge. Now make the bathtub the Pacific Ocean. The western coasts of North and South America would be struck by water moving at speeds and volumes that have no historical analogue. The eastern coasts, Asia, Australia, would see the ocean floor exposed as the water pulled away. Temporarily, because water sloshes back. At the same time, the sudden stop would send seismic shockwaves through the crust. The ring of fire, the chain of fault lines and volcanoes encircling the Pacific, would respond along its entire length simultaneously. The Mediterranean fault zones, Central Asia, every geologically active region on the planet firing at once. The first hours after the stop would be this. Wind at 1,600 kilometers per hour, stripping the equatorial surface bare. Kilometer-high waves rewriting every coastline on Earth. Earthquakes along every major fault line simultaneously. Volcanic eruptions across the entire ring of fire. Air temperatures at the equator high enough to melt tin. All of it at once. Alex knew none of the specifics. He knew the brown line on the southern horizon. He knew the temperature dropping outside in ways the instruments weren't designed to record. He knew that 2 of his 11 radio frequencies were still working and that neither of them was telling him anything useful. What he knew most clearly was something simpler. The station was at 89 degrees north latitude, less than 100 kilometers from the geographic pole. At that latitude, rotational speed is so close to zero it requires precise instruments to measure. The inertial force he'd felt, that small jolt, the mug moving 3 centimeters, the pen rolling off the desk, was the full extent of what the planet's stopping had done to him physically. 800 kilometers to the south, at 80 degrees latitude, the force would have been stronger, enough to knock a person down, to slide unbolted equipment across floors, to crack windows. At 70 degrees, Scandinavia, Alaska, northern Siberia, strong enough to destroy most structures not built into bedrock. At 60 degrees, the line roughly running through Oslo, Helsinki, Anchorage, the southern tip of Greenland, the math stops being survivable for anything standing above ground. Below 60, the numbers become irrelevant in a practical sense. The station had 9 people in it. Alex started going through the rooms. He found all 8 of the others within 20 minutes. None of them were injured. The jolt had been gentle enough here, gentle being a word that meant something very specific and very local. Irina had a cut on her hand from a glass that had fallen. That was the worst of it physically. They stood in the main room together and listened to the sound from the south. It had changed. Lower now, less of a roar, more of a pressure, the kind of sound that bypasses ears and arrives directly in the chest. Outside, the sky had developed a second layer on top of the brown one, black, moving in a way clouds don't move, more like smoke, like something very large burning very far away and very thoroughly. Nobody spoke for a while. Then Henrik, the Norwegian glaciologist who had been at the station longest and who Alex had always found to be a person of extremely limited patience for anything he considered imprecise, said, "The compasses are wrong." He was holding one out. The needle was doing something needles aren't supposed to do, oscillating slowly, without settling, like it was looking for something it used to know how to find. Alex looked at it for a moment. "Yeah," he said. That was all. Because the compass being wrong meant the magnetic field was already changing, which meant something had happened not just to the rotation of the surface, but to the deeper systems connected to it, which meant the list of problems they were facing had just become longer than any of them were prepared to think about in a single morning. He went back to the window. -44 outside now. He wrote it in the log. The pen stayed on the desk this time. He made sure of it. Here is something most people don't know. The Earth is not a sphere. It looks like one from space, close enough that the difference isn't visible to the naked eye, close enough that for most purposes the distinction doesn't matter. But it isn't one. The Earth is an oblate spheroid, which is a technical way of saying it's slightly flattened at the poles and slightly bulged at the equator. The equatorial diameter is larger than the polar diameter by approximately 43 kilometers. 43 kilometers. That's not a rounding error, that's a significant geometric difference, and it exists for one reason: rotation. When a large body of partially fluid material spins, centrifugal force pushes mass outward from the axis of rotation. The equator, spinning fastest, bulges outward. The poles, sitting on the axis, get compressed. The faster the spin, the more pronounced the bulge. The Earth has been spinning long enough and fast enough that its equatorial region sits 43 kilometers further from the center of the planet than its poles do. This has a consequence that isn't obvious until you think about it. Water flows toward the lowest gravitational potential. On a rotating Earth, centrifugal force effectively reduces the pull of gravity at the equator. The outward push partially cancels the inward pull. So water sits at the equator in a kind of equilibrium, held there by the balance between gravity pulling it toward the center and rotation pushing it outward. Remove the rotation. The centrifugal force disappears. The equatorial bulge, over geological time, will subside as rock slowly flows under its own weight, the way ice flows, the way anything under sufficient pressure eventually moves even if it seems solid. The process takes thousands of years, maybe millions, but the direction is certain. As the bulge subsides, the gravitational landscape of the planet changes. The poles, now sitting in regions of slightly stronger relative gravity, begin to pull water toward them. Slowly. Not the sudden catastrophic movement of the first hours. That was inertia, brute physics, immediate. This is different. This is the planet's gravitational field quietly reorganizing itself over centuries and millennia, redistributing the oceans toward a new equilibrium. The water moves north and south. The equatorial regions, which currently sit at the farthest point from the planet's center, begin to emerge as the ocean level around them drops. Coastlines that have been underwater for millions of years slowly appear. New land, if land is the right word for rock that has been at the bottom of the ocean since before humans existed. At the poles, the opposite. The Arctic Ocean floor, currently hidden under water that sits there partly because the rotational bulge directs it away from the poles, begins to receive more of the world's water. The Arctic deepens. The Antarctic coast, already partly above water, changes configuration as sea levels around it shift. Geologists have a rough estimate for the total water movement, enough to submerge most of equatorial Africa, most of Indonesia, large portions of South America's northern coast, the low-lying regions of Southeast Asia that are already barely above sea level would go under permanently, not in the sudden catastrophic way of the first hours, but in the slow, inexorable way of a tide that simply never goes back out. Meanwhile, the Arctic Ocean floor would rise. New land at the top of the world. Bare rock, scraped clean by the water that had covered it, exposed to whatever the sky above the pole had become by then, which, as it turns out, was something quite different from what it used to be. This would trigger its own seismic response. Not the violent, immediate rupturing of the first hours, something slower. The redistribution of water mass from equatorial regions to polar ones changes the pressure distribution on the crust. Rock that has been compressed under kilometers of water for millions of years suddenly decompresses. Rock in other places receives new weight it hasn't carried before. The crust flexes. Faults that had been stable for geological ages experience new stress. A slow, chronic seismic restlessness. Not catastrophic, just constant. The Earth adjusting to its new shape. Alex found out about the compass problem first. The shape of the Earth, the redistribution of the oceans, these were things he would understand only later, pieced together from fragments. A reading on a pressure sensor that didn't make sense. A satellite image on one of the 2 days they managed to get a partial uplink showing the Arctic coastline looking different than the map said it should. What he noticed in the first days was simpler. The sea ice to the south of the station, the frozen surface of the Arctic Ocean that had been their horizon for 8 months, was behaving strangely. Not breaking up, not melting. Moving. Slowly, almost imperceptibly, but the reference points they'd marked on the ice for instrument calibration were no longer where they'd been. Henrik noticed it first, because Henrik noticed everything first, and then waited until he was certain before saying anything. "The ice is moving," he said one morning, standing at the window with coffee. "Ice always moves," Alex said. "Not like this." Alex looked. He was right. Not like this. The movement was wrong in a directional sense, not the wind-driven drift they were used to, not the current-following patterns the station had been recording for years. This was something underneath, something in the water itself, in the pressure distribution of the ocean basin, slowly and without urgency rearranging what sat on top of it. They watched it for a while. "The planet is settling," Irina said from the doorway. Nobody had a better way to put it. Outside, the temperature had stabilized, -41. The brown layer on the southern horizon was still there, permanent now, a feature of this new sky rather than an event happening in the old one. Above it, occasionally, something moved. Not clouds, not weather in any sense they recognized, but large-scale atmospheric circulation patterns that had lost their organizing principle and were finding a new one. Slowly, the planet settling. Alex went back to the log and wrote down what the ice was doing. Bearing, estimated speed, direction of movement. The numbers were small, the implications were not. But he wrote the numbers anyway, because writing numbers was still something that made sense, and sense was becoming a resource worth conserving. He dated the entry. Then he sat for a moment looking at the date. It occurred to him that the date was now somewhat theoretical. A day was 24 hours because the Earth rotated once in 24 hours. The Earth was no longer rotating. The 24-hour day was a convention from a world that had just ended, and they were all still using it because nothing had replaced it yet. He left the date in. Some fictions are worth maintaining a little longer. On the third day, the aurora appeared. Not the aurora they knew, the clean curtains of green and white that appeared on clear nights at this latitude, predictable enough that the station kept a log of them, beautiful enough that even after 8 months nobody had stopped going outside to watch. That aurora was organized, structured. It followed the magnetic field lines down toward the poles in ribbons, in arcs, in shapes that had enough internal logic that you could almost see the invisible architecture underneath. This was different. This aurora covered the entire sky, not ribbons, not arcs, a diffuse, patchy luminescence that moved in slow pulses, like something breathing, like light underwater. Green, yes, but also red in places, and a colour at the edges that didn't have a clean name. Not purple, not pink, something in between that the eye kept sliding off. Henrik stood outside looking at it for a long time without speaking. "That's not right," he finally said. "No," Alex agreed. "The field is weakening." "Yes." They went back inside. Here is what was happening. At the centre of the Earth sits a solid iron core, roughly the size of the moon. Around it, a liquid outer core, molten iron and nickel, kept liquid by the immense pressure and heat of the planet's interior, circulating in slow convective currents that rise and fall over timescales that make human history look brief. This liquid outer core is electrically conductive. Moving electrically conductive fluid generates a magnetic field. This is not an exotic phenomenon. It's the same principle behind every electric motor ever built, the same principle behind the electromagnets in hospital MRI machines. Moving charge creates magnetic field. The scale here is planetary, but the physics is the same physics. The process has a name, the geodynamo. The Earth is a self-sustaining electromagnetic system, powered by the heat of its own interior, organized by its own rotation. The rotation is the critical word. The Earth's spin causes the convective currents in the liquid outer core to organize, to develop preferred directions, to form coherent large-scale flow patterns rather than random turbulence. The Coriolis effect, the same force that organizes cyclones in the atmosphere, organizes the flow in the core. Without rotation, the organizing principle disappears. The currents don't stop immediately. The outer core is still hot, still liquid, still convecting. But the coherent, large-scale flow that generates a stable, organized magnetic field begins to break down. The field doesn't switch off like a light. It weakens. It becomes patchy, irregular, confused, like a signal losing its source, still present but no longer reliable. Over thousands of years, possibly tens of thousands, it fades. What it protects us from is something that's easy to underestimate because it's invisible. The sun produces a constant stream of charged particles, protons, electrons, ions, moving outward from its surface at between 300 and 800 kilometers per second. This is the solar wind. It isn't metaphorical. It is a genuine particle stream carrying genuine energy, striking everything in the solar system continuously. Those particles damage DNA directly, physically. A charged particle moving at several hundred kilometers per second passes through biological tissue and ionizes molecules along its path, breaking chemical bonds, disrupting the molecular structures that cells use to replicate and function. The body has repair mechanisms for this. Evolution built them, because even with the magnetic field, there's some radiation exposure, from cosmic rays, from the sun during solar flares, from the natural radioactivity of rocks. The repair mechanisms work within certain tolerances. Above those tolerances, the damage accumulates faster than it can be repaired. Cells begin making errors when they divide. Those errors propagate. Some of them become cancer. Some of them affect reproductive cells and become heritable mutations. The immune system, itself built from cells that divide, begins making its own errors. The magnetic field is what keeps the solar wind from delivering a dose that exceeds those tolerances at the surface of the Earth. Right now, it deflects the particle stream. The field lines extend far into space, forming a magnetosphere, a bubble of protected space around the planet. The solar wind flows around it the way water flows around the bow of a ship. Most of the particles never reach the upper atmosphere. The ones that do are channeled toward the poles, where they collide with atmospheric molecules and produce the aurora. The aurora has always been the visible edge of the shield, which is why Henrik knew what the changed aurora meant. The atmosphere provides some additional protection. It absorbs radiation. It has mass that particles have to pass through. Losing the magnetic field doesn't mean immediate extinction. It means the radiation dose at the surface begins climbing. Slowly at first, then faster as the field continues to weaken. The comparison that comes up most often in this context is Mars. Mars once had a magnetic field. The evidence is written in its rocks, ancient magnetized minerals, aligned in patterns that only form in the presence of a global magnetic field, now frozen in place in rock that cooled billions of years ago. Mars once had a dynamo, once had a liquid outer core generating a field, once had a shield. Then the core cooled enough to solidify. The dynamo stopped. The field weakened and eventually became the patchy, feeble remnant it is today. Not zero, but not protective either. The solar wind, no longer deflected, began interacting directly with the Martian atmosphere. It stripped it. Not quickly. Over hundreds of millions of years, molecule by molecule, the solar wind photoionized atmospheric particles and the planet's weak gravity failed to hold them. Oxygen left, hydrogen left, water, which requires both, became impossible at the surface. The pressure dropped until liquid water couldn't exist regardless of temperature. Mars went from a planet that may have had oceans and rivers and a thick enough atmosphere to support liquid water to a frozen, irradiated, nearly airless desert in what is, geologically speaking, not that long a time. That process on Earth would not begin immediately. The magnetic field takes thousands of years to fully decay. The atmosphere buys additional time. The timeline is measured in millennia, not years, not centuries. But the direction is set from the moment the dynamo loses its organizing principle. The aurora that covered the entire sky on the third day was the first visible symptom. Alex didn't explain any of this to the others at the time. He wasn't sure how much of it he had right. He was a glaciologist, not a geophysicist, and what he knew about the geodynamo was the outline rather than the detail. But the outline was enough. He thought about it while he was doing the routine instrument checks that still needed doing, because the instruments were still recording data and the data still needed to be checked even if the context for what the data meant had changed entirely. Outside, the aurora pulsed slowly across the whole sky. Green, red, that nameless colour at the edges. Irina came and stood next to him at the window. "It's beautiful," she said. "It is," Alex said. She looked at him for a moment. "That's not a good sign, is it, when you say it like that?" "No," he said, "not particularly." She nodded once and went back to what she'd been doing. Alex stayed at the window a little longer. The thing about a shield is that you never think about it while it's working. You think about it the moment you can see the gap. He wrote the aurora observation in the log: onset time, coverage, color distribution, intensity estimate, the kind of entry the log was designed for, in the kind of handwriting that suggested everything was under control. Then he closed the log and sat very still for a moment. Outside, the sky continued to breathe. On the 5th day, the sun rose in the wrong place. Alex was awake for it. He'd been sleeping badly, they all had, in shifts that didn't correspond to any biological logic. 2 hours here, 3 hours there, waking up disoriented in ways that went beyond the normal disorientation of Arctic darkness and artificial light. His body was looking for a signal it wasn't receiving anymore, something it had always received and couldn't name until it was gone. He was at the window with coffee when the horizon to the west began to lighten. He watched it for a while without registering what was wrong. Then he registered it. West. The light was coming from the west. He stood there holding his coffee with both hands and watched the sky above the western horizon go from black to dark blue to the pale grey that precedes actual dawn, the same sequence he had watched from the eastern horizon every morning for 8 months, now happening in the completely wrong direction. He didn't wake anyone. He just watched. The sun came up slowly, the way it always does at this latitude. Not the sudden appearance of lower latitudes, but a long, gradual brightening, the sun dragging itself above the horizon over the course of an hour. It looked exactly the same as it always looked. Same colour, same size, same quality of light on the ice. Just west. Here is why. The Earth moves around the Sun in a specific direction, counterclockwise, viewed from above the North Pole. This orbital motion hasn't changed. The planet's rotation stopped, but its orbit didn't. Those are two separate movements, one around its own axis, one around the Sun, and stopping one doesn't affect the other. The Earth is still travelling around the Sun at roughly 107,000 kilometers per hour. That part is unchanged. What created the illusion of the Sun rising in the east was rotation. The Earth spun west to east, counterclockwise viewed from above the North Pole. So from the surface, the Sun appeared to move east to west across the sky. The real movement was always the planet spinning underneath a stationary Sun, but from where we stood, it looked like the Sun was moving. Now the planet doesn't spin. The Sun's apparent movement is now determined entirely by the orbital motion, the Earth moving counterclockwise around the Sun. From the surface of a non-rotating planet, that orbital motion makes the Sun appear to move in the opposite direction. It rises in the west, it sets in the east, everything inverted. Alex thought about every compass, every map, every navigation system ever built on the assumption that the Sun rises in the east. He thought about every culture that had oriented itself by this. Temples aligned to the morning sun, cities planned around it, the word orientation itself coming from oriens, Latin for east, the direction of rising. All of it now pointing the wrong way. He went and got Henrik. Henrik came to the window, looked at the sun for about 15 seconds and said nothing. His face did something complicated that Alex had never seen it do before. Henrik was not a person whose face did complicated things. And then it went back to normal. 6 months, Henrik said. What? That's how long it'll be up. 6 months of day, then 6 months of night. He paused. Approximately, depending on where the orbital position puts us. Alex hadn't gotten that far yet, but Henrik was right. Without rotation, the length of a day is no longer determined by how long it takes the planet to spin once on its axis. It's determined by how long it takes the planet to complete one orbit around the Sun. 1 year. One full trip around the sun, that's now 1 day. 6 months of sunlight on one side of the planet, 6 months of darkness on the other. Not the polar day and polar night they knew from the Arctic. This was different. The polar day here was 24 hours of sun that stayed low on the horizon, circling, dipping but never setting, a quirk of latitude and axial tilt. That was manageable. Their bodies had adapted to it. Badly, but they'd adapted. 6 months of continuous direct sunlight was something else entirely, and 6 months of complete darkness was something else still. The temperature consequences alone. The sunlit side of the planet, receiving continuous solar energy with no nightly cooling cycle, no rotation to distribute heat, temperatures would climb to levels incompatible with most biology. Not immediately, not in weeks, but over months of continuous heating, the day side would become something closer to an oven than a planet. Metal surfaces hot enough to burn, rock faces cracking from thermal stress. Any remaining liquid water evaporating and moving, in the upper atmosphere, driven by the temperature differential, toward the night side where it would freeze. The night side, receiving no solar energy at all for 6 months, would cool toward the minimum that physics allows. Carbon dioxide, one of the main components of the atmosphere, freezes at -78 degrees Celsius. Given enough time and cold enough temperatures, it would begin precipitating out of the night side atmosphere as dry ice, settling on the surface, accumulating. An atmosphere that freezes on one side of a planet is called atmospheric collapse. It's a scenario planetary scientists discuss in the context of tidally locked exoplanets, worlds orbiting close enough to their star that tidal forces have stopped their rotation and locked them face on. The question of whether life could survive on such worlds, whether the atmosphere survives, whether liquid water persists anywhere, these are open research questions with models pointing in different directions. The Earth would be one of those worlds now. Alex knew none of the technical terminology for this. He knew that 6 months of sun, followed by 6 months of dark, was not a situation any of the station's systems had been designed for, and that their food supply was calculated in weeks rather than months, and that the heating system ran on fuel that was also calculated in weeks rather than months. He filed those thoughts away. Then he thought about the stars. "The stars don't move anymore," Irina said that night. She'd been outside doing an instrument check, something they were still doing because the instruments were still there and the habit was still there, even if the purpose had become somewhat abstract. She came back in and said it the way you say something you noticed but didn't want to notice. Alex had been waiting for someone to say it. Without rotation, the stars no longer travel across the sky. What made them appear to move was the same thing that made the sun appear to rise in the east. The planets spinning underneath them, the observer rotating through space, the stars staying fixed while the ground moved. Take away the ground moving and the stars stay where they are. Every night for the rest of your life, you would see the same stars in the same positions, the same constellations, fixed, unmoving, like a painting of a sky rather than an actual sky. For the first months after the stop, this would be disorienting in a way that's difficult to articulate. Human beings have been reading the movement of stars for as long as human beings have existed. The stars moving was not just navigation. It was evidence that time was passing, that the night had a direction, that morning was coming. The slow wheel of the sky overhead was one of the oldest clocks in existence. Now the clock had stopped. There was one exception, the moon. The moon hadn't stopped. It continued orbiting the Earth on its own schedule, unaffected by the planet's rotation stopping. The orbit is determined by gravity and momentum, neither of which changed. The moon moved across the frozen starfield on its own timeline, completing one orbit roughly every 27 days. In a sky where nothing else moved, it was the only thing that did. Alex watched it one night from outside, standing on the ice in the cold that had become, if not comfortable, then at least familiar. The stars were fixed. The aurora, still present, still covering most of the sky, still doing things auroras weren't supposed to do, pulsed slowly. And across all of it, the moon moved. Slowly, deliberately. 1 degree every few hours, barely perceptible if you watched it directly, obvious if you looked away and looked back. He stood there for longer than was practical given the temperature. There was something about the moon still moving that mattered in a way he couldn't fully formulate. Everything else had stopped. The planet, the sky, the reference points that made the world legible. The moon hadn't gotten the message. It was still going, still following its own path, still doing what it had always done, carrying its stolen rotation patiently across a sky that had otherwise gone completely still. He thought of something his father had told him once, about ships in fog. When you can't see anything, you find the one thing that's still moving and you keep it in sight. He went back inside, wrote the moon's position in the log. Then, because the log was becoming less of a scientific record and more of something else, a proof, maybe, that time was still passing even if the sky no longer showed it, he also wrote what the aurora had been doing and what the western horizon had looked like that morning, and the exact quality of light that the wrongly placed sun had put on the ice. Details. Specific, physical, particular details. It was the only navigation he had left. Alex closed the log. Outside, the aurora was doing what it had been doing for 7 days now, covering everything, breathing slowly, green and red and that colour at the edges that still had no name. The moon was somewhere above it, moving. He knew that without looking. He had one more entry to make before he slept. Day 7. Temperature stable at -41. Ice movement continuing. Bearing unchanged. Speed unchanged. Compass still wrong. Aurora coverage. Total. Moon position. Logged separately. Tomorrow we decide. He capped the pen. The decision was already made, really. Henrik had shown him the math 3 days ago and the math hadn't changed. The Terminator was moving. The night side was getting closer. At some point, not tomorrow, but not far from tomorrow, staying at the station would stop being a choice and become a consequence. What he didn't know yet was what the Terminator actually was. What lived there, what the climate was doing without the systems that had always organized it. What it meant to walk into a place where the wind came from 2 directions at once and never stopped. What it meant to follow the only strip of a stopped planet that still had liquid water. He would find out. So will you. Part 2, next week.